Hi everyone, welcome back to the channel. Today I'll be covering coordinate geometry from Pure Maths 1 of A-level Mathematics. We'll be covering different equations of lines, formulas and rules, and a couple of questions. So first off, there are three different forms of equations of the line that you should be aware of. The first one is already familiar to you, that is y is equal to mx plus c. So over here, c is the y-intercept, and it is a constant, and m is our gradient, and is always with x. So when we input certain values of x, we should get corresponding values of y, and that will give us our line. The next form you should be aware of is minus y1 is equal to m x minus x1. So over here, y1 and x1 are actually coordinates which will be given to us. And m obviously is the gradient. So this can actually be used as a formula where we're given the gradient, or we calculate the gradient and find the gradient, and we're given that the line passes through a certain coordinate. I will further show you in questions how exactly we can use this formula. When you rearrange this formula, you'll see that it's actually the formula for gradient, which is y minus y1 upon x minus x1 is equal to m. Now the next form you should be aware of is ax plus by plus c is equal to 0. This is essentially when y is not the subject of the formula. Now, you should be careful with this because first we'd have to make y the subject of the formula, and then we can determine what the gradient is and what the y-intercept is. So if I made y the subject of the formula over here, that would be y is equal to minus c minus ax upon b. Therefore, the gradient over here would have to be the coefficient of x. In this case, that would be minus a by b, because essentially this form can be written as minus c by b minus ax by b. So the coefficient of x would be negative a by b. So m, or the gradient, would be negative a by b. Sometimes you're asked to write your equations in this form, ax plus by plus c is equal to 0, or you're given it in the question and you're expected to work with it. So now we'll be covering some formulas and rules. So the first formula is for the length of a line, or the distance between 2 points. So if we're given point A and point B, the distance between the 2 points would be root of x2 minus x1 whole square plus y2 minus y1 whole square. It's the root of the entire thing. So essentially, it's actually applying the Pythagoras theorem. The reason why is because A would have the coordinates of x1 and y1, while B would have the coordinates of x2 and y2. So if I found the difference between x2 and x1, that would be this distance over here. And if I found the difference between y2 and y1, that would be this distance over here, this length over here. So if I square both of the distances, add them, and then root them, I'll be applying the Pythagoras theorem to find the distance AB, because now this is a right angle triangle. So how exactly do you know which point would be x2, y2 as opposed to being x1, y1 and vice versa? So it's always the latter points in the graph that will have the higher value. So it's always the latter points that will be x2, y2 instead of x1, y1. Because we know that in the graph, the values always increased up and to the right. So the latter points will always be higher as in x2, y2, and the prior points would be x1, y1. The next formula we'll be covering is the midpoint between 2 points. So that would be for the x coordinate x2 plus x1 upon 2, and for, sorry, not the bracket, and for the y coordinate it would be y2 plus y1 upon 2. Essentially, we'd first be finding the midpoint of the x-coordinate and then the midpoint of the y-coordinate. So this is for x and this is for y. Now the next rule we'll be covering, or formula, is the gradient. This is something you already know. That's y2 minus y1 upon x2 minus x1, which is the gradient. Next, we'll be covering some properties that you should know about lines. Is that for parallel lines, they have the same gradient. And for perpendicular lines, which are also denoted like this, as in they have a 90-degree between them, they have the gradient, or the product of the gradients is -1. So m2 here is the gradient of the second line and m1 is the gradient of the first line. The product of the two will give you -1. So if I knew what the gradient was for the first line, which is m1, and I'd have to find out what m2 is, or the gradient of the second line, I would get m2 is equal to -1 by m1. So essentially, it will always be the negative and the inverse of the gradient of the first equation. Sometimes if my first equation already has a negative gradient, because I'll be making it negative again with the -1, the final gradient will actually end up being positive. Now the next property you should know is for parallelograms. So the first one is that they'll always have the same midpoint. As in, if I sketched one right now, here this midpoint would be the same between the two corners. And opposite sides have the same length. So this line and this line, basically the parallel lines, will have the same length. And because this line and this line are also parallel to each other, they will also have the same length to each other. And another thing is that because they're parallel, they will have the same gradient. As we discussed earlier, that parallel lines have the same gradient. So now we'll be moving on to some questions. So the first question, we have to find the equation of a line that passes through the point 4, -3, and it is parallel to y plus 2x is equal to 7. So to find the equation of this line, we'd need its gradient and its intercept. But we can't calculate the gradient using the usual formula y2 minus y1 upon x2 minus x1 because we're only given one point. You would need 2 points to use that formula. So in this case, we can actually use the rule we discussed in equations of the line, which is y minus y1 is equal to m x minus x1, because we can find out what the gradient is and we already have a coordinate. So how do we know what the gradient is? Well, we know that it's parallel to this equation over here, therefore the gradient is supposed to be the same. So what is the gradient of this equation? It's not +2 because y is not the subject of the formula. First, we have to make y the subject of the formula. When we do, we get minus 2x plus 7. So the gradient for this equation is -2. Because it's parallel, the gradient will also be -2 for the next equation. So when we substitute our gradient and our coordinates into the equation, we get y minus -3 is equal to -2x minus 4. So that's y plus 3 is equal to -2x plus 8. So that becomes y is equal to minus 2x plus 5. Now for the next question, I suggest pausing the video and trying to solve it on your own, and do so for all of the other questions. So for this, we have to find the points of intersection of two equations or two lines. The equation of the first line is 2x plus 7y is equal to 47. And for the second line, it's 5x plus 4y is equal to 50. Now, what we would normally do is that we'd be given our equations, or at least in IGCSE, we'd be given our equations in the form y is equal to mx plus c, and we would equate both of the equations to each other, and then we would solve for x. After finding what x is, we would input that into either one of the equations to find out what the y coordinate is, and then you'll have your coordinate for where the lines intersect. In this case, however, y is not the subject of the formula, and making it the subject will be a little messy because y has a coefficient. Instead, what we could do is, because we need to find out what x and y is, we can solve it using simultaneous equations. We're given two equations and we're given two variables. We can cancel one of the variables, find out what one of the variables are, and then substitute it into any one of these equations, and then find out what the other variable is to find the coordinate. So two ways of solving simultaneous equations are either by elimination or by substitution. Substitution again is a bit messy, that's why it's best to go with elimination. And first I'd like to eliminate variable x. To do that, I will multiply this equation with 5 and this equation with 2, so that they would both have 10x, and when I subtract that, 10x will be removed. So the first equation becomes 10x plus 35y is equal to 235. The second equation becomes 10x plus 8y is equal to 100. Now when I subtract these two equations, 10x minus 10x is 0, so x is removed. Then 35y minus 8y gives me 27y. 235 minus 100 gives me 135. So y becomes 135 upon 27, and that is equal to 5. Now I can substitute this in either the first or the second equation to find out what x is. So if I do 2 into 5 plus 7, oh sorry, substituting it in the wrong way. If I do 2x plus 7 into 5 is equal to 47, that's 2x plus 35 is equal to 47. So 47 minus 35, and then that divided by 2, I should get 6. So the coordinate for the point of intersection is 6, 5. Now it's only one point of intersection because the final equation which we have is linear, as you can see over here. If instead it was quadratic, then we would have 2 points of intersection. If it was quartic, we'd have 4 points of intersection, and so on. Now for the next question, we have to find the equation of a line that goes to the point -2, 5 and is perpendicular to the equation y is equal to 3x plus 1. We also have to find the points of intersection. So we can find out what the gradient is using the equation which we're given, and then we can use our coordinate to find the equation of the line, and then we can equate the equations to each other or substitute them or eliminate them. It depends on how the equation is, and then we can find the variables to find out what the coordinates are. So firstly, let's try and determine what the gradient is. In this equation over here, y is the subject of the formula, so we can immediately take the coefficient of x to know what the gradient is. And over here, that is 3. Because the two lines are perpendicular to each other, the gradient of the perpendicular line will be -1/3, because it's a negative and the inverse of the first line. So the gradient of the new line which we're trying to find will be -1/3. I'll denote this by m2. Now when I substitute that into my equation of y minus y1 is equal to mx minus x1, it would be y minus 5 is equal to -1/3 x minus -2, which is basically +2, So that's y minus 5 is equal to negative 1 by 3x minus 2 by 3. So that's y minus 5 is equal to negative 1 by 3x. Minus 2 by 3 plus 5 becomes plus 13 by 3. So that is y, sorry, this isn't supposed to be here, is equal to, now if I take out 1 by 3, I'd have negative x plus 13. So if I take 3 to that side, it will be 3y is equal to negative x plus 13. This is the equation for the second line or the new line. Now to find the points of intersection, I can equate the equations to each other. But right now I'll choose to substitute the first equation into the second one because it seems easy to do. So 3 into 3x plus 1 is equal to minus x plus 13. I substituted this equation into this one. So that's 9x plus 3 is equal to minus x plus 13. That's 10x is equal to 10. So x is equal to 1. Now if I substitute that in either one of these equations, for example, y is equal to 3 into 1 plus 1, I end up getting 4. So the point of intersection over here is 1, 4. So next we'll be solving a question from a past paper. I'm not sure which one it is because I took it from classifieds, but it has two parts and we won't be solving the second part because it's not a lesson we covered yet. So we're given this diagram and we're told that the curve has the equation y is equal to 2x squared. We're also given the coordinates of the 2 points xp. We're also told that q lies on the curve and that the line pq is parallel to the y-axis. Now we have to express the area A of the triangle xpq in terms of p. So the formula for area of a triangle is half into base into height, or half AB sine theta. But there's no point doing the second one because there is no angle we have to work with. Unless you do want to try and find the angle using trigonometry, but that's unnecessary. So B over here is our base, and that is essentially the distance xp. So to find the distance xp, it would basically be the difference between the x coordinates. So that would be p minus negative 2. So that's essentially p plus 2. So that's what the length of our base is. Now our height over here will be the distance qp. So we don't have the coordinates of q, we have the coordinates of p, and we know the distance between qp will basically be the difference of the y coordinates of qp. So we know obviously that q will have the same x coordinate of p, but we don't know what y is. The reason why it has the same x coordinate as p is because it is right above point P. So because we have the x coordinate for point Q, we can actually input that into our equation of the curve to find out what the y is. The reason why is because we know that Q lies on this curve. So if I put x is P, which is the x coordinate of point Q, it will be 2p squared. So the coordinate of Q would basically be p comma 2p squared. Now the distance qp will basically be 2p squared minus 0. So it will just be 2p squared. And now because we have the base and the height, we can input that into our area for the formula for the area. So that would be half into the base over here was p plus 2, and then the height over here was 2p squared. So we can simplify this. Half and 2 will cancel each other out. So it will be p squared into p plus 2, and that's p cubed plus 2p squared as the area of the triangle. So now we'll be solving another question from classified past papers. So we're told that the diagram shows a trapezium ABCD which AB is parallel to DC, and angle BAD is 90 degrees. So it's a right angle. The coordinates of A, B, and C are given to us, and first part we have to find the equation AD. So we don't know what the coordinates of D are, and we don't know the gradient of the line AD either. But we do have the coordinates of A and B, so perhaps we can find the gradient of AB, and because AD is perpendicular to AB, we can apply the rule where m1, m2 is equal to -1 to find the gradient of AD, and then we can use that in our equation y minus y1 is equal to mx minus x2. So for question number 1, the first thing we'll do is find the gradient of AB. So that would be y2 minus y1 upon x2 minus x1. So y2 over here is -3 because B is the lateral point, minus 6 upon 5 minus 2. So that becomes -3. And because that's the gradient of AB, we now know that the gradient of AD will be 1 by 3. Because if this is -3 and then m2 is equal to -1, essentially m2 would be -1 upon -3, which becomes 1 by 3. So we have the gradient of AD now, and we have one of the coordinates of the equation of the line AD. So we can input that into our formula y minus y1 is equal to mx minus x1. So y1 over here is 6, that's the coordinate for A, is equal to the gradient is 1 by 3, x minus x1 over here is 2. So that's y minus 6 is equal to 1 by 3 x minus 2 by 3. So that becomes y minus 6, y is equal to 1 by 3x minus 2 by 3 plus 6 becomes positive 16 by 3. So when I take 1 by 3 out and I move it to the other side, it becomes 3y is equal to x plus 16. And this is the equation of the line. Now for the second part, we have to find the coordinate D. So the way we can do that is by equating the equation of AD and the equation of CD to each other to find their intersect, which is point D, as I've annotated in the diagram. So we know the equation of AD is x plus 3y is equal to x plus 16. So we'd have to find the equation of DC. Now for the equation of DC, what we're missing is our gradient. Well, because DC is parallel to AB, their gradients will be the same. And I know already from the previous part that the gradient of AB was -3. So the gradient of DC is also going to be -3. So for the equation, it will be y minus y1 is equal to mx minus x1. So that is y minus 3 is equal to -3x, and x1 over here is 8 minus 8. So that's y minus 3 is equal to -3x minus 3 into -8. That's positive 24. So that becomes y is equal to -3x. Now 24 plus 3, that's positive 27. And this is our equation for DC. So now I can equate the equations of AD and DC to find my intersect D. So when I equate that, I can simply substitute equation DC into equation AD, or I can make y the subject of the formula in AD, but things become a little messy in my opinion at least. So I'm just going to substitute DC into AD. So DC over here is -3x plus 27, and AD over here is 3y, so 3 into minus 3x plus 27 is equal to x plus 16. So that's minus 9x. Now 27 into 3, that's 81, plus 81 is equal to x plus 16. So then that becomes 81 minus 16, which is 65, is equal to 10x. So 6.5 is equal to x. Now we have the x coordinate of D. We have to substitute that in either one of the equations to find out the y coordinate. So I'll substitute it in equation DC. So that's negative 3 into 6.5 plus 27. When I do that, I get 7.5. So the coordinates of D are 6.5, 7.5. Now for the third part, we're told that point E is such that ABCE is a parallelogram. Okay, so our trapezium changes into parallelogram. There are multiple ways this can happen. One of them can be that this point C comes down here, but actually if we do that, we end up making a rectangle, so that shouldn't be correct. Perhaps another way we can do it is by extending point D upwards, so that this is where point E lies, or we extend A downwards over here, so this is where E lies, to make this and this parallel to each other. But let's see, in the question it says that ABCE is a parallelogram. So A has to be one of the vertices. So as you can see, D is not mentioned as a vertex, therefore we're actually changing point D to the new location of point E. So what I said over here is the correct form of the parallelogram. I'll just erase this extra over here to clear the space up. So now we know what the parallelogram might look like, and we're asked to find the length BE. So we have to find E first, and then we can find the distance between BE. So in order to find E, we would have to find out what AE is and CE and intersect those two to find point E, and then we can find the distance BE. Now to find AE, we can do what we've been doing in the other two parts as well. So the gradient for AE will be the same as the gradient for BC because they'll be parallel to each other. And if I remember correctly, we found the gradient of BC. Did we? No, it doesn't look like we did. So we can find the gradient of BC easily using the y2 minus y1 upon x2 minus x1 formula. Because C is the latter point, it will take the values of x2 and y2. So it will be 3 minus negative 3 upon the x coordinate over here is 8 minus 5. So that's 3 plus 3, which is 6. 8 minus 5 is 3. So 6 by 3 is 2. So the gradient for BC is 2. Because the gradient of BC is 2, the gradient of AE is also 2. Now to find the equation of AE, that'll be y minus y1 over here will be the coordinates of A, which is 2, 6. So y minus 6 is equal to m over here is 2, x minus the x coordinate is 2, So that'll be y minus 6 is equal to 2x minus 4. Y is equal to 2x minus 4 plus 6 is positive 2. So the equation for AE is 2x plus 2. Now for the equation of CE, we already have the gradient, which is negative 3. Over here is the gradient. And it's the same gradient because essentially it's following along the same slope, point E, I mean. So we have the gradient and we have point C. So we can easily find out what equation CE is. Actually, I believe the equation CE is the exact same as equation CD because the gradient is the same. There's no change happening. So if we applied the y minus y1 is equal to mx minus x1 formula, we'd end up in the exact same equation. So if I can equate those two equations to each other, let's see. The equation of DC we already found over here. And if I equate that to this equation over here, so minus 3x plus 27 is equal to 2x plus 2. I can solve for x. So that becomes 5x, and 27 minus 2 is 25. So x would therefore be 5. And when I substitute that into either one of the equations, let's take the second equation, AE, that'd be 2 into 5 plus 2, so that's 12 for y. So essentially the coordinates of E would be 5, 12. And now because I have coordinate E and B is already given to us, B is 5 and negative 3, I can input both of them into our formula for finding the distance between 2 points. So that would be, in this case over here, E is the latter point. Actually, they both have the same x values, but the y value of E is higher, so I'll consider E to be the latter point. So if I did root of 5 minus 5 whole square plus 12 minus negative 3 whole square, root the entire thing. 5 minus 5 is 0, so that would be root of 12 plus 3, which is 15 square. So root of a square, they just cancel each other out, so that's equal to 15. So my distance BE is equal to 15. So that is it for this lesson. I hope it made sense. If you have any other doubts or questions you'd like us to solve, please leave them in the comment section below. If this lesson helped, consider liking and subscribing. And I'll see you in the next video. Thank you.